integral square root of 1 minus sin 2x dx. We will see how to solve this question. We know that sin square x plus cos square x is equal to 1. Also we know that sin 2x is equal to 2 sin x cos x. ಹಾಗಾದ್ರೆ ಇಲ್ಲಿ ಕನ್ಸಿಡರ್ ಮಾಡಿ ಸ್ಕ್ವೇರ್ ರೂಟ್ ಆಫ್ 1 ಮೈನಸ್ sin 2x ಅದನ್ನ ಹೀಗೆ ಬರ್ಕೊಳ್ಳೋಣ. 1 ಅಂದ್ರೆ cos ಸ್ಕ್ವೇರ್ x ಪ್ಲಸ್ sin ಸ್ಕ್ವೇರ್ x ಮೈನಸ್ sin 2x ಅಂದ್ರೆ 2 sin x cos x. ಈಗ ಅಬ್ಸರ್ವ್ ಮಾಡಿ ಸ್ಕ್ವೇರ್ ರೂಟ್ ಒಳಗಿರುವಂತಹದ್ದು a ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ b ಸ್ಕ್ವೇರ್ ಮೈನಸ್ 2ab ಈ ತರಹ ಇದೆ. ಇದನ್ನು ನಾವು a ಮೈನಸ್ b ಹೋಲ್ ಸ್ಕ್ವೇರ್ ಅಂತ ಬರ್ಕೋಬಹುದು. ಹಾಗಿದ್ರೆ ರಿಕ್ವೈರ್ಡ್ ಇಂಟಿಗ್ರಲ್ ಬಿಕಮ್ಸ್ ಸ್ಕ್ವೇರ್ ರೂಟ್ ಆಫ್ cos x minus sin x whole square. So root is eliminated, that is required integral is cos x minus sin x dx. That is integral cos x andre ನಮ್ಗೆ ಗೊತ್ತಿದೆ it is sin x and integral sin x is minus cos x. ಹಾಗಾದ್ರೆ ಇಲ್ಲಿ ಮೈನಸ್ ಸೈನ್ ಇರೋದ್ರಿಂದ ಪ್ಲಸ್ ಆಗುತ್ತೆ, ಪ್ಲಸ್ cos x plus c. That is option D is the right choice. We have integral 1 plus cos square x by sin square x. Let us consider the required integral here, that is 1 plus cos square x by sin square x dx. We will divide this each term by sin square x. ಅವಾಗ ನೋಡಿ required integral becomes 1 by sin square x dx plus integral cos square x by sin square x dx. 1 by cos square x andre it is cosecant square x. We know that sin square x ಮತ್ತೆ sin x ಮತ್ತೆ cos x ರೆಸಿಪ್ರೋಕಲ್ಸ್, ಅದರಿಂದ 1 by sin square x ಅಂದ್ರೆ cosecant square x ಆಯಿತು. ಹಾಗೆ cos square x by sin square x ಅಂದ್ರೆ cot square x ಆಗುತ್ತೆ. ಈಗ ಇಂಟಿಗ್ರಲ್ cosecant square x is minus cot x, ಅದನ್ನು ಬರ್ಕೊಂಡ್ಬಿಡೋಣ. ಈ cot square x is cosecant square x minus 1. Cot square x is equal to cosecant square x minus 1, or we have this formula cosecant square x is equal to 1 plus cot square x. ಇದರಿಂದ ನಾವು cot square x is equal to 1 minus cosecant square x ಅಂತ ಬರ್ಕೊಂಡಿದ್ದೀವಿ. ಈಗ here I have minus cot x plus integral cosecant square x ಅಂದ್ರೆ ಮತ್ತೆ ನಾನು ಇದನ್ನ minus cot x ಬರಿಬಹುದು, and minus 1 ಇದೆ, that is integral minus 1 dx here, that is minus 1 dx means it is minus x plus c. So we have minus 2 cot x minus x plus c. This is the required integral, minus 2 cot x minus x plus c, which is in option C here. Integral sin inverse of cos x dx. So let us see how to integrate this given integral. We know that cos x is nothing but sin of pi by 2 minus x. Therefore I is equal to integral of sin inverse of cos x dx can be written as integral of sin inverse of cos x can be written as sin of pi by 2 minus x here. We know that sin inverse of sin x is x here, that is sin inverse of sin of pi by 2 minus x can be written as pi by 2 minus x dx here. So let us integrate both these terms. This pi by 2 is constant, integral k dx is kx. Therefore, integral pi by 2 dx is pi by 2 into x minus integral x is x square by 2. That is, when you take 2 as LCM, I have pi x minus x square, which is option C. Integral dx by tan x plus cot x is equal to, we will see how to evaluate this. Let us write tan x in the denominator as sin x by cos x plus cot x can be written as cos x by sin x. Now you can take LCM in the denominator, that is cos x sin x is the LCM here. Now numerator here, that is sin x into sin x is sin square x plus cos x into cos x is cos square x, which is nothing but 1 here. Sin square x plus cos square x is 1, we know. Now the given integral becomes, you can take this cos x sin x to the numerator here, that is given integral becomes sin x cos x dx, and sin square x plus cos square x is 1 here. We can ignore that. Now I is equal to integral sin x cos x dx can be written as 1 by 2 into 2 sin x cos x dx. I am multiplying and dividing by 2. Now 2 sin x cos x is nothing but the formula sin 2x dx. Now integral sin 2x is minus cos 2x by 2, that is minus cos 2x by 2 plus c. So answer is minus cos 2x by 4 plus c. That is, the required integral is minus cos 2x plus cos 2x by 4 plus c. Option D is the right choice. We'll see how to evaluate this integral of e to the power of a log x plus e to the power of x log a. Let me mention two properties. One is k log x is equal to log x to the power of k, and a to the power of log x to base a is x. Let us use these two properties here. First, you can consider e to the power of a log x. E to the power of a log x is nothing but e to the power of log x to the power of a. That is, k log x equals log x to the power of k. A log x is equal to log x to the power of a. If nothing is mentioned here, I have base e. Now e to the power of log x to the power of a to base e. That is, you can apply this property 2 here, which is nothing but x to the power of a. Similarly, e to the power of x log a is nothing but e to the power of log a to the power of x. That is, k log m equals log m to the power of k. And this is nothing but a to the power of x here. That is, base is here e. So e to the power of log a to the power of x to base e is a to the power of x. Now the given integral becomes integral x to the power of a plus a to the power of x dx. So now this is a standard integral. Integral x to the power of a is x to the power of a plus 1 by a plus 1, and integral a to the power of x is a to the power of x by log a plus c. You can observe the answer is x to the power of a plus 1 by a plus 1 plus a to the power of x by log a plus c is in option C. If f dash of x equals x square plus 5 and f of 0 equals minus 1, then f of x is equal to, we have 4 options as usual. Now we need to integrate this f dash of x here to get the value of f of x. So let me consider what is given here, that is f dash of x is equal to x square plus 5. Let us integrate on both sides. So we get integral f dash of x is f of x. On the right hand side, integral x square is x cube by 3 plus integral 5 dx is 5x plus c. It is given that f of 0 is minus 1. Here f of 0 is equal to 0 here. When you put x equals 0, I have 0 cube by 3 which is 0 plus c here. But it is given that f of 0 is minus 1, so we can equate here, that is c is equal to minus 1. Therefore f of x, that is from this equation 1, say equation 1 here, that is f of x equals x cube plus 5x plus c. F of x is equal to x cube by 3 plus 5x minus 1. So required value of f of x is x cube by 3 plus 5x minus 1. That is option C here. Let us evaluate integral of tan inverse of square root of 1 minus cos 2x by 1 plus cos 2x. We know that cos 2x is equal to 2 cos square x minus 1. That is 2 cos square x is equal to 1 plus cos 2x. So denominator in the given problem, that is 1 plus cos 2x here, can be written as 2 cos square x. Similarly, we know that cos 2x is equal to 1 minus 2 sin square x. So 2 sin square x is equal to 1 minus cos 2x. So numerator of the problem, that is 1 minus cos 2x, can be written as 2 sin square x. That is, given integral I becomes integral tan inverse of square root of 1 minus cos 2x is nothing but 2 sin square x, and 1 plus cos 2x is nothing but 2 cos square x dx. So I is nothing but tan inverse of square root of tan square x, because sin square x by cos square x is tan square x and 2 is eliminated here. So I becomes tan inverse of tan x, that is root of tan square x is tan x dx, which is nothing but tan inverse of tan x is x here. So required integral is I is equal to integral x dx, which is nothing but x square by 2 plus c, which is in option C here. Let us evaluate dx by square root of x plus root of x minus 2. I consider 1 by root x plus root of x minus 2 first, and let me simplify this first and then I will integrate. This 1 in the numerator can be written as x minus of x minus 2 divided by 2. You can observe here x minus x is 0 and minus of minus 2 is plus 1. Minus of minus 2 is 2 and 2 divided by 2 is 1 here. And in the denominator I have root x plus root of x minus 2. Now let us multiply and divide by the conjugate of the denominator, that is root x plus root x minus root of x minus 2 by root x minus root of x minus 2. We know that a plus b into a minus b is equal to a square minus b square. Now the denominator is root of x plus root of x minus 2 into root x minus root of x minus 2. That is a plus b into a minus b is a square minus b square. Now denominator becomes root x whole square minus root of x minus 2 whole square, which is nothing but x minus of x minus 2. Now this required integral I becomes 1 by 2 integral. Numerator is I have x minus of x minus 2 into root x minus root of x minus 2 here, divided by denominator is x minus of x minus 2, x minus of x minus 2, which will be eliminated. So we get 1 by 2 integral root x is nothing but x to the power of 1 by 2 minus root of x minus 2 is nothing but x minus 2 to the power of 1 by 2. Now we can easily integrate this. That is 1 by 2 x to the power of half plus 1, that is 2 by 3 x to the power of 3 by 2 minus x minus 2 to the power of half is nothing but 2 by 3 x minus 2 to the power of 3 by 2. When you multiply by 1 by 2 here, we get 1 by 3 or 2 by 3 you can take common, so that we get 1 by 3 into x to the power of 3 by 2 minus x minus 2 to the power of 3 by 2 plus c, which is in option A here. 1 by 3 x to the power of 3 by 2 minus x minus 2 to the power of 3 by 2 plus c. That is option A is the right answer. So let us see how to integrate sin x by sin of x minus alpha dx. Let me consider I first, that is sin x by sin of x minus alpha. I have x minus alpha in the angle of the sin in the denominator. That is why I will write this numerator sin x as sin of x minus alpha plus alpha. Therefore, we can apply the formula of sin of a plus b, compound angle formula, as sin a cos b plus cos a sin b. Therefore, numerator will be integral sin of a plus b as sin of x minus alpha cos alpha plus cos of x minus alpha sin alpha divided by sin of x minus alpha. I am applying the compound angle formula, that is sin of a plus b sin a cos b plus cos a sin b. In the given integral, this numerator sin x is written as x minus alpha plus alpha. Therefore, this numerator sin of x minus alpha plus alpha can be written as sin a cos b here, that is sin of x minus alpha cos alpha, and cos of x minus alpha and sin alpha. Now let us divide each term by sin of x minus alpha. So we are left with cos alpha dx plus integral cot of x minus alpha, because cos of x minus alpha by sin of x minus alpha is cot of x minus alpha into sin alpha into dx. So you can notice that cos alpha and sin alpha are constants. So integral cos alpha dx is nothing but cos alpha into 1 dx, which is nothing but x, plus sin alpha is constant, and integral cot of x minus alpha is log of sin of x minus alpha plus c. So now you can identify the right option, that is ABCD. In ABCD, among ABCD, x cos alpha is in option A and B, and sin alpha, here I have plus sign, so plus sin alpha into log of sine of x minus alpha plus c. That is option B is the right choice. Integral cos x minus 1 by cos x plus 1 is equal to, we have four options as usual. Let me consider I as integral cos x minus 1 by cos x plus 1. I will take minus common in the numerator so that I becomes 1 minus cos x divided by cos x plus 1 can be written as 1 plus cos x. Now let us apply the formula. We have 1 minus cos x is equal to 2 sine square x by 2 and 1 plus cos x is 2 cos square x by 2. We have 1 minus cos x divided by 1 plus cos x, so that this 1 minus cos x by 1 plus cos x becomes 2 sin square x by 2 divided by 2 cos square x by 2, which is nothing but tan square x by 2. Therefore, I is equal to minus of integral tan square x by 2. But tan square x by 2 is equal to integral of, here I have secant square x by 2 minus 1 from trigonometry. We have this formula, secant square x by 2 is equal to 1 plus tan square x by 2. From this, tan square x by 2 equals secant square x by 2 minus 1. Let us multiply by the negative sign so that we will get integral 1 minus secant square x by 2. So let us integrate term by term. Integral 1 is x and integral secant square x by 2 is tan square tan x by 2 divided by 1 by 2. That is, I have 2 tan x by 2 plus c. Therefore, required integral is x minus 2 tan x by 2 plus c. X minus 2 tan x by 2 plus c is in option D.